Hi, everyone. Buenos dias. That's as much Spanish as I'm going to speak today. I also know a very long phrase in Spanish that a friend of mine taught me a while ago, but it's a very bad one. So I can tell you later in private. I can say it on stage, especially if this is recorded. So my name is Abdel. I'm a developer advocate at Google. I've been in the industry for a while. I've been doing a lot of things. I'm CNCF ambassador, and I live in Sweden, and I'm from Morocco, just south of here, just a few kilometers south. As a developer advocate, we get to do this. Like, we get to do talks and stuff. But one of the things I actually like is working on real cases, real projects. And what I'm going to be telling you over the next 30 minutes or so is what I learned from real projects I actually worked on with AI. And because I like analogy, that's my kind of teaching side, I came up with this thing, Open Sesame. I think you know probably the Alibaba and the 40 Thieves, right? Everybody knows the story? OK, cool. All of you know, probably. So every company, every enterprise has some sort of cave of wonders, I call it. Your cave of wonders is a legacy application that somebody built a long time ago, and you probably don't know how it works. You just deal with it. It's just there. It works. It's happening. And we have this kind of culture in our industry, which is if it's not broken, don't fix it. If it ain't broken, don't fix it. Which basically means if things works, just don't touch it. Because most of the time, actually, most people or most developers, what they want to do is they want to ship new stuff. Almost no one wants to refactor existing things. I don't know if this is actually a thing in the industry, but at Google at least, no one actually gets promoted for fixing shit. Everybody gets promoted for shipping stuff. So if you spend a month refactoring a library, no one is going to give you a promotion. But if you ship a new button, then you get promotion, right? So we got approached by this company. It's a Swedish-based company. I'm not going to mention the name. But they basically said, hey, we have this existing application. It's 100,000 lines of code on Ruby. And none of the developers in that company write Ruby. It came from an acquisition. They acquired an existing company. They had this code base. It works. And they just dealt with it, right? So 100,000 lines of undocumented Ruby code, the worst. So it's both code they don't understand, and it's also undocumented. And it's a monolith application. And what this application does, basically, is that so the company is a content distribution company. So they distribute content, PDFs, files, audio, video, stuff like that, right? So they get the content from the producers, the publishers. Think about the companies that actually make the content. And then they distribute through their platform to their customers. So one of the things they have to do is they have to ingest all this content, and then they have to process it to make it available to their users. So that could be things like audio files, which could be extremely long, think about audiobook. An example that we actually had in this particular project is The Time of War, which is one of the most popular audiobooks. It's about 80 hours of audio content. And to process this particular file, it took their existing system 80 minutes, and it costed $80. The 80 is not a coincidence. It's just like a particular example. But it could be any sort of thing. But the much larger problem they had is that they actually, when they make their application available in new markets, let's say they enter the Spanish market, they actually have to publish even more content. They have to create a catalog, right? Which means that their system has to suddenly process hundreds and hundreds of thousands of audio files to make it available in this particular new market. So they had this system, and they basically acted as wood chippers. So as developers dealing with existing code bases, legacy applications, you are a wood chipper. You're just basically hacking at an existing code, one Jira ticket at a time, trying to make sure it works, trying to make sure it continues working. The leadership, the engineering leadership in this company, they decided, well, this is not going to work. The main problem also is that this monolith application, when it fails, they have to restart it manually, right? Like, there is no automation. So the engineering leadership decided we need to fix this. So they sit down and they said, OK, how much would it take to rewrite this entire application? And they estimated it's a 2 full developer year for 9 months to re-architect the entire system. So they have to take from the existing pool of developers 2 people and just task them with rewriting the entire system, right? For a year almost, or 9 months. And we all know that doesn't work, right? How many of you have been on these projects where there is a system that exists? Here, one person, two, and then 3, 4, 5, okay, more hands. And then some of your colleagues are trying to rewrite it at the same time, but you have to keep it working at the same time, right? And the problem is, as time evolves, needs evolves, business needs evolve specifically. So it's not only a rewrite, it's almost all the time a rewrite and evolve, right? Your system is not frozen in time, because as you are rewriting the system, suddenly your marketing team will show up and they're like, oh, you know what? It would be nice to have this new feature, right? And then your commercial team will show up and they're like, it would be nice to have this new feature. So it's almost never a complete re-architecture. It's a re-architecture and feature addition, right? And most of the time, actually, as developers, you can just push back and say, no, no, no. Like, talk to us in 9 months. Let us do our thing, and then it's not going to work. So basically, we came up with this model where we said, OK, we have AI tools. And AI tools are actually very good at producing new code. You probably have heard of this term, code is becoming a commodity. No, AI can generate new code, so we don't really need developers, blah, blah. So we said, let's see how these tools can actually work on an existing system. And specifically, what we wanted to do is we didn't want to task 2 developers to read the existing system 1 line at a time and then rewrite it 1 line at a time, because that would take 9 months, right? If you are familiar with the Alibaba and the Forty Thieves, there are these 2 main characters in Alibaba, in the tale. There is Qasim, who is Alibaba's brother, and there is Morjana, or Morjana in Arabic. So Qasim is a wealthy, rich person who is the brother of Alibaba. And when Alibaba found the cave, Qasim entered the cave, got lost in all the gold he found there, and then eventually forgot the keyword to exit the cave. And then was stuck inside the cave, and then the thieves found Qasim. So that's the equivalent in our analogy of rewriting applications 1 line at a time, right? Morjana was more clever, because what Morjana did is that she actually tagged the exits of the cave with multiple, to like confuse the thieves for where they are. So she was tagging the different exits. She was exploring different paths, right? So what we did is we said, OK, instead of rewriting this application 1 line at a time, let's follow the path of using AI to explore how the existing application works. So we took anti-gravity and Gemini CLI, doesn't matter what the tools are, and we integrated this into the existing system. So we took the existing code base, we took the CLI, and we ran the code base against the CLI. This can be done with codec, with Cloud Code, doesn't really matter the tool. But the whole idea was, instead of using the AI to actually write the code, we use the AI to understand what the code does, right? Most importantly, we use the AI to explore what we call the CUJs, the critical user journeys. So explore all the code paths and document what the code actually does. So the output of the AI was not code, it was just documentation, right? And then this next step was starting with TDD, test-driven development. So instead of actually directly from the documentation starting to write code, we wrote tests first. We generated them with AI, and then we verified them by person. But the whole idea is write code that can verify that the new system, which is not built yet, will actually do the exact same thing as the old system. That's test-driven development. So we did that as the first step. So this took about 3 weeks, where we went through this iteration of writing some skills and writing some agents.md, so mostly like markdown files, and then running the AI or the CLI tool against existing code base, and then generating documentation. And we ended up with like really cool diagrams and really cool like CUGs, and the file gets uploaded, blah blah blah, stuff happens. So instead of following the path of Qasim, which is the trap in this analogy, where we would just dive into the existing code and rewrite it 1 code at a time, and then eventually get lost in that particular code base, we followed the path of Morjana, which is exploring the code path 1 path at a time, 1 potential output at a time, and then rewriting or writing test-driven development to verify that the new code, which is not written yet, will adhere to what the existing code does. So that was the loop. So the agent proposes things, we run some tests, we catch some errors, we automate the feedback, and then we repeat. And then we started the implementation. So the implementation was, okay, here is the code base, here is the COJs and the documentation. Now write code that adheres to these particular COJs, and that will make those existing tests work. One error actually we caught very early, and this is just learning experiences. There's a couple of errors we caught. One of the most important errors we caught is most AI, what they do is that if you give them tests to write, to adhere to, and they will have to write code that will pass the tests, what they will do sometimes is that they will just decide, oh, the test doesn't pass, so I'm just going to delete the test. So I'm gonna ask you to like bear with me for a second here. I know it's 9 a.m. in the morning, so I know you're all caffeinated. If a test fails, if you delete the test, it will not fail. That is a valid solution. It's not what you want, but it's a valid implementation, right? Same thing for a database. Same thing for anything, right? From the point of view of an AI, just deleting the problem is part of fixing the problem. You know? That's the equivalent of actually when you move. So imagine you move from one place to another. You have all these boxes. I just moved like 3 years ago, and I still have nightmares from that move. You have all these boxes that you are not going to open at some point. So what do you do with them? You put them in a closet. Because they're away of you. You don't see them. So they're not a problem anymore. You don't think about them, right? So we had to actually go through this loop of writing code, making sure the tests pass, making sure the AI actually doesn't delete the tests. And if you're wondering how we do that, it's through hooks. You can basically, any agentic AI tool today, you can write hooks, and in the hooks, you can prevent it from doing things. So skills and agents.md sometimes is not enough. The rules are sometimes not enough. So you can actually write code to prevent the agent from doing certain things. And one of the things you can prevent it from doing is deleting existing files, right? Deleting tests. So that's one thing. Then what we did, the next step is basically ask the AI to actually generate 3 versions of the same system. One was in Java, one was in Python, and one was in Go. Because the AI is so good at generating code super fast, what we wanted to do is being able to test or to prototype. So generating in 3 different languages give us the possibility to actually test every language on cloud and see which one actually makes more sense, which one is faster. And I'm going to let you guess which one was faster at the end of this. I'll tell you, I'll give you the answer at the end. The other thing we did also is that we actually noticed that the system was primarily an orchestration system. So the ingestion is a file, an audio file, let's say, that gets through this entire long pipeline, which has a chokehold or a bottleneck. And the bottleneck was the monolith application, which was slow, it has to be restarted, blah, blah, blah. But then when we really looked at how the COJs were generated, we realized that it was just an orchestration system. An orchestration system is any system that basically takes a bunch of files as an input and then passes them through a bunch of business logic steps to generate an output. Now, some of you might say, with the orchestration system, we can just use any other tool to orchestrate, orchestrate code, right? Argo CD workflows, whatever tool you want to use for orchestration, that's the only example that comes in mind. But the problem is because the existing developers had to maintain the system, they never really had an opportunity to stop and think about the entire logic end-to-end. They just had like a monolith application that just works. So we very quickly realized what we could do actually is we could decouple this monolith application. Now, again, some of you might say, oh, this is just an example, a typical example of monolith to microservices re-architecting, right? Flash news, dude, what the fuck are you talking about? Actually, a lot of times when you are deep into the weeds of the cave, you don't really have time to think about how your stuff works, right? And this system, among everything this company does, is by definition a microservice. Because the company doesn't only have this. They have multiple other code bases doing all sorts of things. They have front-end applications, they have back-end applications, they have databases. So from their perspective, they just see this as one component in a very large diagram of existing components doing all sorts of things. So they don't really think about it as an orchestration system. They just think, oh, it's just an app that does a specific task. So, and I know, like, I did this talk to a smaller group before at a test run to this. And somebody was like, yeah, but like anybody could think rewrite an orchestration system should be easy. Just like convert it into a microservice application. I will give you a counter argument. 3 years ago, some people at Amazon actually published an article where the title of the article was something around the lines of like migrating from microservices to monolith saved us 90% of the cost. So they had an application that's basically ingested Amazon Prime videos, the live stream, and then they did some quality analysis on those videos. And the existing system was written in microservices, which basically ingest videos using AWS existing systems, SQS, Lambda, blah, blah, blah. And then they realized that by actually taking this and converting it into a monolith application, running it on the virtual machine, they could save costs. So the argument of converting something from monolith to microservice or microservice to a monolith, most of the time is a fanatical, opinionated argument that people are either arguing for one system as like the thing to do or the other one as the thing to do. But it doesn't matter because everything is important in context. And the context is what are you trying to achieve? In this particular example, moving from monolith to microservice made sense. But it could have been that a different system or a different application or different use case, a monolith actually makes more sense. So converting this to a microservice architecture where we have ingestion, like we have an ingestion pipeline, we have a pub sub sitting in between, so like a publisher subscriber system, and then we have an orchestrator. And in the orchestration layer, we used actually a combination of code and cloud systems. On Google Cloud, we have this thing called workflows. It could be any sort of Airflow, Apache Airflow equivalent system that you have, or Argo CD or whatever, or Argo workflow, sorry, which would allow you to actually parallelize the processing. So we could take, instead of taking one file, trying to process it one file at a time, we could take one file and just submit it to a job and then get the job to process that file. Again, this is something we couldn't actually figure out from looking at the application from outside. We had to dive in, use an AI tool to document what this thing does. So the result was a total of almost 8 weeks iteration, 4 weeks plus homework, for the same existing book that took 80 minutes and costed $80 with our new implementation in which programming language? I'm going to say in, and this, you just shout a programming language from the 3, Java, Python, Go. In all of them? Okay, I didn't hear the others. I'll get started again. In? No, Java was actually the slowest. So in Go, it took actually 2 minutes and costed $0.28 to process, which means suddenly we could process even more files when we enter a new market, right? So one of the things I learned from this particular project is watching, because the project was us from Google, plus people from the company, like developers from this company, together for a week, hacking together code, using the AI tool to generate the code, validating it, blah, blah, blah. I noticed kind of 2 profiles of developers when it comes into AI. There is the developer type that follows AI suggestions as we all follow terms of sales things, which is scroll, 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 accept and continue, right? Whatever the AI said, it doesn't matter how you're using it, just like accept. Do you want me to change 200 lines of code? Yes, please, do that, whatever, right? And then there is the other ones, or the other profile, which I fit in more, which is you see what the AI is suggesting to do, and then you either accept it, redirect the AI, or sometimes even ignore it and implement it yourself. Because actually, a lot of times, you are much faster at implementing things than you spending time writing a prompt and waiting for the AI to think and then suggesting a fix or an implementation. And so if you are familiar with this, there is this thing called the 7 stages of grief. When you have somebody in your family passing out, As an industry, when AI came, I think we have all faced these 7 stages of grief. I call that the 7 stages of Agentic AI. And the 7 stages of Agentic AI is like shock, anger, blah, 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 and then at the end, it's acceptance. So I'm going to walk you through these stages. Stage number 1, using AI as a search tool. Ignore this is a Gemini, it can be whatever, right? Using AI as a search tool. So instead of using Google or using Stack Overflow, you are literally just Googling things using an LLM. And then taking whatever the LLM tell you and using that. This feels like ages ago. This was 3 years ago, 2023. Then the next step is when the CLI started popping up, Claude Code, Codex, Gemini CLI, Antigravity CLI, whatever, using it with manual intervention. So you would prompt, you would wait for it to plan, you would probably review the plan, see what the code changes look like, and then accept it or reject it, right? Stage number 3 is you would still trust what the AI does, but put in place guardrails. That's around the time when agents.md, skills.md started popping up, where you would try to direct the AI to do certain things a certain way. Like give it some rules, give it some instructions, instruct it to be a front-end developer, a back-end developer. As a, as a wannabe Java developer, because I like to hang out in the Java circle quite a lot, and a very, very bad front-end developer, this is actually my favorite stage. I just tell it like, hey, do this way. I don't really care what you're doing. I don't really like to do front-end code. I don't like TypeScript. I don't like JavaScript. I don't like CSS, HTML. Just like, I trust you, whatever. Just do it. As long as it looks beautiful, it's fine by me. It might not look the best. But the point is, you are like guiding the AI in doing certain things. Stage number 4, sorry, is when you primarily start with your AI as a primary tool. So you start there first, and then you kind of orchestrate it. You switch to, like, you skip the editor, or maybe you use an AI editor like Cursor, but you use the AI or the prompt chat as your primary interface. And then code becomes a second thing, right? You start first with the prompts, and then you look at the code second. Stage number 5, if you are super cool, and I should have had my sunglasses on, that's what I call YOLO mode. YOLO mode is you start the tool, and you just go like, approve everything. Do not ask me any questions, just whatever. So I actually, in this particular project, I noticed that a lot of people default to this, YOLO mode. YOLO mode could be, don't ask me for approval, or it could be just start the tool in YOLO mode and just like implement it in YOLO mode. So this actually was an interesting experience in this particular project, because what we ended up with is one of the reasons the Java implementation was actually very slow is that the person who was doing the Java implementation was using the AI in YOLO mode. As in, he was not actually checking anything. He was just letting the AI generate whatever and just accepting whatever. So I'm sorry for the Java developers in the room. Java is a very verbose language. It generates a lot of lines of code. It likes a lot of lines of code, which is completely fine. But in YOLO mode, it actually generates even more lines of code. And the reason why it was slow is not because the code was bad or Java is bad, it's because the code that was generated was not optimized. Stage number 5 is when you become the orchestrator. Have you seen this meme on social media where people take a picture of them holding a laptop open and walking with it to the break and say like, oh, my agent is working, so I can't close the laptop? You've seen this before? That's essentially the orchestrator, right? You just like fire up your CLI, maybe 3 or 4 of them. You get each to work on one Jira ticket, and then you keep your laptop open 24/7, and then you hope that by the time you come back from your bathroom break, one of your bugs have been fixed, right? Then stage number 7, the last one. That's the architect. That's when you feel you are the master of the universe. That's actually when you don't even use an AI as your chat interface. As one of the CTOs of Spotify have attested on a podcast recently, one of my most of Spotify developers wake up in the morning, they type a prompt into Slack, and by the time they get to the office, they have a pull request ready to review. I mean, it's wishy-washy. It's the thing that we want to live. Sounds to be like 2060 or 2070, like a couple of years from now, or a couple of tens of years from now. But I don't think we're there yet. I don't think we are in a mode where we can actually completely trust what an AI can do. I think we still have to verify, as developers, what it's doing. We still have to be the orchestrator. I think at this point, we're probably not even at this stage. Because as I said earlier, one of the key things we learned, or I learned personally from these projects and from using AI in general, is that a lot of times you still have to guide the AI, to like kind of orchestrate it, to watch what it's doing, to validate every single step. And somebody asked me this 2 weeks ago. I was in a conference, and I got this question, which I think is going to be the most important question going forward for most developers, is how do you shift focus, right? Let's assume that you have 3 different terminals working on 3 different problems. How do you actually focus or shift focus from one to another? So each time you switch from one problem to another, how do you context switch, right? Not in the context of AI, what context for LLMs is, but you as a human. How do you switch from one context to another? And we already know that actually a lot of developers have a hard time already just switching context between the editor and chat, Slack, chat, whatever tool you're using, right? Because a lot of times you get interrupted, people ask you questions, something break in production, you get a Jira ticket, maybe you are holding a pager, you get called because there is a problem in production. So how do you context switch? And getting to this level is going to be even harder because you will be basically context switching most of the time or almost all of the time. I think this is sort of the future, in my opinion, where you become the architect. You become the person that explains the how and why. Sorry, explain the why, not the how. And then you just hope or wish or think or expect the AI to do things, right? And then the next level over this, which is stage 8, which doesn't exist in the 7 stages of grief, is basically auto-approve. So it's the architect plus auto-approve, which is you just prompt something, and then you get another AI to confirm what the first AI does, or use different tools to do different things. Some people already does that. I was talking to Stefan Janssen, who is the founder of DevBcn, and he told me that he's already doing this, actually. But my counter argument to Stefan was like, there is nothing at stake in what you're doing, because he's doing a conference. Like, what's the worst that can happen? If the schedule of the conference is down most of the year, no one cares. We only need it during the 5 days of the conference, right? If the website is down most of the year, no one cares. So it really depends on what's at stakes, what's the most important thing you're trying to achieve. If you are building a system that displays a bunch of text on a web page, and the web page is unavailable for a month or for a week because the AI did something wrong, fine. But if you are building a system that allows people to book tickets for trains, for flights, hotels, banking systems, then maybe this is not the thing you want to be doing. You want to actually be more here, or rather stage 4, which is you actually prompt the AI, use the AI as your first tool, prompt it, but still verify and then approve every single step. So the conclusion of all of this is that I think we are all going toward the future where instead of starting to chop or to wood chop one Jira ticket at a time, one problem at a time, one bug at a time, where we need to start thinking about how can we actually switch from this into using the AI in our advantage. And using it in our advantage does not necessarily mean replacing us, but rather using it to maybe verify an existing code base, read an existing code base, understanding an existing code base, and rewriting that eventually in some form, in one shape or another. I started my opening talk by saying that most of developers actually don't get promoted because they are fixing existing stuff. Most people get promoted because they're shipping existing stuff. Well, now I think we can actually get promoted because we're fixing existing things, because fixing it will take less time, generally speaking. So with that, I hope this was useful. I hope I teach you something today. And thank you so much. Muchas gracias.
Is there time for questions?
I do have time for questions,
I mean,
yes.
5 minutes. So
yes.
Any questions?
Hi.
Hi.
Well, my question was, I'm in a similar situation right now where I'm trying to use AI to, well, try to help me understand some legacy code. And one of the issues that I found is mostly the edge cases, especially when they propagate not within the code that the AI is reviewing at the moment, but rather how it propagates to another system. So I don't know if that was something that you guys faced or how you solved it.
Yeah, so the way we solve that is by also ingesting into the existing AI the interface of that code. So the interface being the API spec, right? So we ingested that as part of the documentation to tell the AI that basically whatever you produce has to end up adhering to this interface as much as possible. And there are some edge cases that would be like an input has a space or some sort of escape characters or things like that. There isn't really a magic fix for now. The only way you could do it is you have to write like super strict tests to fetch those edge cases. So the beauty of all of this is that actually you could use AI to come up with the potential edge cases. So you could generate them. You don't have to use them, but you could generate them at least, and then look at them, and then review if they actually make sense for your particular system or not, right? But there isn't really, so we had this, like one of the things we had was, one of the problems we had with this is that most AI coding tools are written assuming people speak English, but that's not always the case, right? So a lot of the audiobooks titles, they're not always in English. Sometimes they're in Arabic, sometimes they're in French, sometimes they're in Chinese, whatever. So we had to write kind of a lot of edge cases to verify those particular systems. And because when you write Arabic or you write French, for example, or you write English, it's not, it's right to left, left to right, whatever. So you have so we had to like look at these cases one case at a time. And also we had to test with as many variations of the edge cases as possible. So whatever makes sense for you as edge case, what I would do in your case is I would start with those and write tests for those first. So start with the test for the edge cases first, and then move on to the rest. Make sense?
Yep.
All right.
Thank you.
Thank you.
Hi.
Any other questions?
Can you hear me?
Yeah.
Yeah.
I don't see you.
I'm here.
Ah, okay. I see you now. Ah, hey.
Hey.
Hey, man.
Hey. So, okay, I'm going to ask a question about cost.
Ah.
So, let's suppose that we have a setup where the AI is allowed to retry, let's say, 15 times, which I think is pretty standard. A lot of people are doing that. I've seen cases where the token and compute cost for a CI run that fails and times out after 15 goes is $125.
Yes.
And that is at current price. I don't know if you saw, but the OpenAI's financials have leaked. Was it Anthropic's? Anyway, their losses have widened 8-fold since last year. So that means that they are currently underpricing the tokens by a factor of 8. That points at a price point for a failed CI run of $1,000 per run in the worst case. Obviously, these are worst case numbers. That doesn't sound great.
Yes, I agree with you.
So if this is really the way that our craft is going to go, how are we going to pay for it? I don't see my management paying for CI runs that cost $1,000 or even $1,000 a day.
Very good question. I love the question. So there are two answers to this particular question. Obviously, the first answer is that I agree with you in the sense that eventually, at some point, AI will start costing even more than developers, right? Because the key difference between an AI as a developer is that AI has universal costs. It doesn't matter where it is. But developers are paid differently depending on which country they live in, right? Like a developer based in California will cost more than a developer based in India. It's just the reality. So if I remove my kind of like Google hats and I put in my fan of large language models kind of in production hat, I think that part of the future is that actually companies will start running their own large language models. So I don't know if you have looked at Kimi 2.5 or some of the Gemma stuff that Google released recently. They're actually pretty good. And one of the things that's actually, I think one of the things that is missing, there is a key component to this puzzle that is missing yet, is a lot of times when you're using a tool to do coding, right? It doesn't matter what the tool is. It might have auto switch, which is it uses different LLMs based on the task that you give it, right? In my experience, I noticed that like 90% of the time, it just will use the most general, most expensive large language model. So in my case, I'm using anti-gravity CLI. I have access to Gemini 3.5 Pro, 3.5 Flash, 3.1 Pro, and 3.1 Flash. The 3.1s cost less than 3.5, but when I look at the metering, it actually uses 3.5 most of the time. Even if my question is just look up something in documentation, which clearly you don't need a 3.5 kind of model to do, right? So one of the key components that is missing yet is actually a proxy running on your browser, on your editor, that can read the prompts, and based on the complexity of the prompt, can decide which is the most optimum large language model to call. And that doesn't exist today, right? That's one thing. The second thing is that clearly you don't need a very large capable model to do most tasks. You need it to do the most complex tasks. You need a capable model. But most tasks can be achieved by a model that runs on your laptop, right? So I think the future would be two things. Either we get to a point where we run in hybrid mode, which is you have on-device inference, so you have a model running on your laptop that doesn't slow it down, but it still runs perfectly. And then you have a component that can automatically switch between it and cloud. That's one possibility. Or the second is you still have this model running on your laptop, and then your company has its own models running on its own hardware. Because by running on hardware, you can achieve two things. You have predictable TCO, total cost of ownership, right? You just buy servers, buy GPU, run a model, and that's it. You don't have to pay ongoing costs. That's one. And then the second thing is you have privacy also. You don't trust that your editor or your CLI will upload your code into the cloud to a vendor that you don't trust. Like, I don't know if you saw recently, but Anthropic, when they released Fable 5 and Metos 5, they basically, in their term of sales, they said, no, we use your data to train the models, right? So the future is this. It's a hybrid mode, which is you run between something that runs on your laptop, and either you as a developer, you have to manually switch, or you have a smart component running on your editor, on your CLI, that will switch between on-device and then cloud. And then, now that I'm talking about this, there is one more thing I'm actually thinking about. In this particular experience I had, we need to cut, yeah, I'm just going to finish this sentence, guys. In this experience I had, I noticed something. A lot of times when people are actually talking to an AI, they don't specify which file they want AI to look at. So a lot of them, they allow you to do like ads and target a particular file. They don't do it. They just say, like, fix this problem. And then the AI has to spend thousands of tokens looking through the existing code base to actually find the particular bug. So that, of course, also could be an optimization layer, which is you target a very specific file. Make sense? All right, thank you so much. Thanks.
Thank you.